So now that we've reached a third type of function or rule, all right, let's before we start this task, let's go ahead and look at the three rules we have now. Right now we know we have an arithmetic sequence, right, which leads to a linear function, right? And we know that has what we call a common difference, right? So when we look at the pattern, right, if we notice a common difference, we know it's arithmetic or linear. Then we have a geometric sequence, which leads to an exponential function, right? And that has what we call a common ratio, meaning we're multiplying by the same amount each time. The new type of function we have, right, is called a quadratic function. And what this sequence has, right, is it has a common second difference. Okay? So basically when you take the first difference, take that difference again, and that should be common throughout. So when we look at 1.3, right, after looking in the mirror and feeling flabby, Scott decided that he really needed to get in shape. He joined the gym and added push-ups to his daily routine. He started keeping track of the number of push-ups he completed each day in the bar graph below. With one day showing he completed 3, after 4 days, Scott was certain he could continue this pattern, increasing the number of push-ups for at least a few months. Okay, so we had to model the number, or the number of push-ups each day, right? Could we write an explicit and recursive equation to model this? Well, let's look at first what type of function are we going to have. So when we make our table, we have x, we have f of x. So on day 1, he had 3 push-ups. Day 2, he had 5. Day 3, 7. Day 4, 9. So right away when we look here, what is going on each time here? I know I'm not multiplying by the same amount. Here I go up 2. Here I go up 2. I go up 2. So this here right away tells us 1, it's arithmetic, which means the function is linear, and that the common difference is 2. So right away, when we go to write the explicit rule, which is probably the most important out of all of them, f of x equals my slope, or rate of change, is the common difference, so it's 2. And I'm going to use the first day I had 3 push-ups. I'm going to use this information to write my explicit rule. So f of x equals 2 times x minus the x coordinate, which is 1. Then I started with 3, so plus 3. And that would be my explicit rule. Now, the recursive rule, remember, we're going to start by showing what we had on the first day. So on day 1, we had 3. So now, what are we doing to the previous term each time? We went up 2, so we add 2. And that would be your recursive rule. Okay? But here's the thing. This is going to change up a little bit. Scott's Gym is sponsoring a Macho March promotion. The goal of Macho March is to raise money for charity by doing push-ups. Scott has decided to participate and has sponsors that will donate money to the charity if he can do a total of at least 500 push-ups, and they will donate an additional $10 for every 100 push-ups he can do beyond that. So now Scott is going to track the total number of push-ups done up to any given day of the month, right? So this is the key part, right? So it's understanding what they're asking. So when we look at that, what they're asking is like day 1 we did 3, But how many push-ups for the month did he do on day 2? Well, if he did 3 the first day, 5 the next day, on day 2 he's done a total of 8 push-ups. The 3 for the first day, 5 for the second day. So that's where this is going to change up a tad bit. Okay? Now, do me a favor, take a second to estimate the total number of push-ups that he can do in a month if he continues to increase the number of push-ups he does each day in the pattern above. Okay, and that means going back to the beginning of the task. So the next part says draw a diagram that shows the total number of push-ups that Scott has done in the month at the end of each day. So remember, this is changing a little bit, right? So a diagram will help understand what this is saying. So after day 1, Scott has done his 3 push-ups. But after day 2, it's going to be the 3 push-ups from day 1. And now we're going to include the 2 additional ones, right? So he did 3 on day 1, right? 5 on day 2. So how many total has he done for the month so far on day 2? 8. On day 3, he had the 3 he did on day 1. He had the 5 he did on day 2. And now he has the 7 he did on day 3. So when you look at day 3, how many push-ups has he done so far? Right? 12 plus 3 is 15. So now when we go to make this table, it's a little different, right? Now this table, x, f of x, day 1 is still 3, but day 2 now is 8. Day 3 would be 15. If I look at day 4, right, you have the 3 plus the 5 plus the 7 plus how many now? 9. So on day 4, right, how many would he have done? Well, if I take 15 and add the 9, it would be 24. So using this pattern, how many push-ups would he have done after 1 full week? Well, if we look at this pattern continuing, right, day 4 he did 24, and that's because we added 9 to day 3. So now if we add 24 and 11, that would be 35. If we add 35 and 13, that would be 48. And if we add 48 and now he's going to do 15, that would be 63. So after a week, he would have done, for the month so far, 63 push-ups. Now this is where it gets a little difficult. Model the total number of push-ups that Scott has completed on any given day during Macho March. Include both the explicit and the recursive. Right now, our first goal is to start with the explicit, right? The recursive, is actually a little more difficult for these, so-called quadratic functions, right? And we're going to see that in a minute. So before we go in look at the explicit, let's first determine what type of sequence and function we're going to be working with. When I look here, right, the pattern it shows, we're not multiplying by the same amount, and in here we go up 5, and we go up 7, then we go up, 9? Okay, so right away, this doesn't have, the first difference is not common. But we could check to see if the second difference is common. So, what is the difference between 5 and 7? It went up 2. What did it go up here? 2. So again, up here we went up, from here to here we went up 11, which means that would be 2. So when we look at this, this has a common second difference, which tells us right away that this is going to be a quadratic function. And if it's a quadratic function, right, our explicit rule will look something like ax squared plus bx plus C. Okay, and that's, you know, something that we have to kind of understand. So to speed things up, I kind of made an outline of the chart on the side here, but I also drew the diagram out. If you remember in 1.2, we doubled the number of blocks to create rectangles and used the idea of area to help us with this. And we're going to do the same thing here. So in the first one, right, we started with our original 3 blocks, right? And remember, if I do this to one of the figures, I have to do it to all. So if I double the number of blocks, right, I add the 3 and I get a 1 by 6, which tells me I would have an area of 6 blocks here. Now, over here, if I highlight the yellow ones, I have, you know, 8 yellow ones. If I add 8, it doubles, so I know my area would be 16, and it ends up being a 2 by 8 rectangle. And so on. The next one, we double it, we get 30 blocks, so our area here would be 30. And if you look here, remember, the number of push-ups he did on day 1 was 3. The number of push-ups after day 2 he'd done for the month is 8, right? So when we look at the area or the blocks here, right, although we get double the number, if we divide that by 2, 16 divided by 2 is 8, 30 divided by 2 is 15, okay? But it's much easier to find the area of a rectangle than it is, you know, a crazy looking object, right? So let's look at how this area comes about. After day 1, right, can I say the area is 1 times 6? The next one is 2 times 8, and the next one ends up being 3 times 10. Well, what do we notice about the first number in each of these? That number, right, is the same as the day of the month. So this is day 1, this is day 2, this is day 3. So if we say the days are going to be the variable n, we're going to say n ends up being the first part of our explicit rule. But now when you look at it, we have 6, we have 8, we have 10. Can we write a rule for this? Right? Another thing, I'm going to look at it 2 ways here. Okay? I'm going to go over here and tell you that the cool thing about these quadratic functions is the second difference tells us something. So if you look at the first difference, right? If I look at the first difference, what this does is this grows in a linear fashion. This grows in a constant way. But what happens is this ends up being, right, the product of 2 linear functions. So right away when I look here, right, I went up 6, 8, and 10. Can we figure out that linear rule right there? So if you think about it this way, think of it after day 1, we had 6. After day 2, we had 8. Okay? And if I just write the linear rule here, if I find the rate of change or the slope, right, that's going to be 8 minus 6 over 2 minus 1. My slope would be 2, hence the second difference, right? And if I go ahead and plug that in, f of x equals 2 times x minus 1, right? I took that 1, plus 6. And in this case, I would get 2x minus 2 if I distribute the 2, plus 6, which gives me 2x plus 4. Now, where does this 2x plus 4 come from, right? Another way I want you to think about it, right? So you could do this. You could do n times 2x plus 4. N times 2x plus 4. I should say 2n plus 4. Sorry about that. I should have used n down here. Now, if that's the case, right, think about this. if I take the day, which is 1, and I multiply by 2 times the day plus 4, that would give me 1 times 2 times 1 is 2. 2 plus 4 is 6. Is 1 times 6 going to give you 6? Yeah. If I go to day 2, n is 2. So 2 times 2 times 2 plus 4. Right away here, 2 times 2 is 4. 4 plus 4 is 8. 2 times 8 is 16. Isn't that how many blocks I had here? So what this ends up being is, the second difference and all that gives you a way to find the two linear functions that multiply to give you this quadratic function. Now, is this very difficult to understand? Not going to deny it. It's not easy, right? But I want you to look at it another way. If we look at this as I went from 3 blocks, right, to 8 blocks. So I went up 5, I went up 7, I went up 9. So if you think about it this way, right, I went up 3, then I went up 5, then I went up 7, then I went up 9. If I look at this sequence and I write a rule for it, my rate of change is 2. And then if I say this is day 1, x minus 1 plus 3, I would get 2x plus 1. How does this differ from this? Well, if I add the original 3 I started with, that would give me 2x plus 4. Okay? So, when I look at this now, the explicit rule, the way we need to approach it is the day times 2 times the day plus 4. But here's the thing. That would give me double the number of push-ups. So what I have to do is divide by 2. Now, if I go ahead and do this, that'd be 2n squared plus 4n all divided by 2. And right away, if I divide each of these terms by 2, 2n squared divided by 2 is n squared. 4n divided by 2 is 2n. And right away, if I look at this, right, you could have f of n equals n squared plus 2n. Or for the explicit rule, I would allow you to say f of n equals n times 2n plus 4, all divided by 2. And after all that, some of you guys are probably saying, well, can't we also just say that this ends up becoming, if I divide this by 2, it would be n times 2 divided by 2 is n, plus 4 divided by 2 is 2. And if you look here, right, if I were to use this one, would that work? And some of you may have noticed that, I could just take the number of days and multiply it by the number of days plus 2, right? Does that work? And that's something to think about, right? So if I look, would this work? So March has 31 days. I can use any one of these explicit rules to help me. If I use the first one, f of 31 equals 31 to the second power plus 2 times 31. If I plug that in my calculator exactly the way I see it, 31 squared plus 2 times 31 is going to give you 1,023. So in the month of March, he would do 1,023 push-ups for the month. Okay? So did Scott reach his goal? His goal was 500, right? So he reached it, plus he went over by 500. So he reached his goal, and for the additional 500 push-ups, right, he will get another $50. Okay? So, with all this in mind, it's pretty important to understand a couple of things here. All right? So to basically summarize everything for 1.1 to 1.3, okay? 1.1 to 1.3. We now have three functions we work with, right? We have linear, right? We have exponential, and then we have quadratic, okay? Now, linear functions have a common difference, okay? So when we look at a table, we see that it goes up, the same amount each time. An exponential function has a common ratio, which means we multiply by the same amount. A quadratic function has what we call a common second difference. Okay? And that's important to understand. Also, if it's linear, your graph will be a straight line. If it's exponential growth, right, it'll look something like this. So that's exponential growth. Decay would look something like this. Now the graph of a quadratic, right, if I take the function we just did, all right, which is n times n plus 2, or even better, n squared plus 2n. If I were to create a table of values, and I just start at, say, 0, if I plug 0 in, 0, 0 is an ordered pair. If I plug 1 in, 1 squared is 1, plus 2 times 1 is going to be 2, 1 plus 2 is 3. So if I plot these ordered pairs, 0, 0, 1, 3, I would get this. If I go 2, right, 2 squared is 4, 2 times 2 is 4, 4 plus 4 is 8. So you get 2, 8. So now if we go the other way though, right? If I look at this, if x is negative 1, right? Negative 1 squared is 1. 2 times negative 1 is negative 2. 1 plus negative 2 is negative 1. So negative 1, negative 1. Let's go to negative 2. Negative 2 squared is 4. 2 times negative 2 is negative 4. 4 plus negative 4 would give me 0. And even if I go to negative 3, negative 3 squared is 9. 2 times negative 3, excuse me, is negative 6, right? 9 minus 6 is 3. So negative 3 is what I would get here. And what you see is a graph of a quadratic is in the shape of a U. And if we have a shape of a U, what this is called, the lowest point is called the vertex. Okay? That's the lowest point of the graph. Now, we're not going to go ahead and graph these yet. You should be able to create a table of values. But knowing what a parabola is, what the graph of a quadratic is, and the name of that is a parabola, is important. And you could always use a table of values to do that. And if you were to write this table of values, and I look, what point would end up being the vertex? That negative 1, negative 1. this is your vertex, and if you look at 0, 0, then if we go -2, 0, and then you go 1, 3, and then you go -3, 3, what you'll see is what we call symmetry, right? If this is a vertex, these points are the same distance away from the vertex. Okay? So I know this is a long video. I apologize.